Welcome back to the cool dark place. It's 91 degrees in the house and close to that outside. Yeah, taking refuge from the heat, having a glass of chilled, I believe a Pinot Noir from 2010. So farting around with some Arduino circuitry, switches, and the Arduino integrated development environment. And I'm trying to get my space warp drive switching system project underway. I was originally going to talk about switch bounce in the context of Arduino. Many of you have run into that before. Instead, I'm going to talk about noise. Bounce and noise are somewhat related because in the end we want a good signal to noise ratio, and in switching components we want no noise whatsoever. Enter Arduino or what have you. It all goes to shit quite rapidly. So here's the scenario. You've got some kind of Arduino-based thing happening over here. It doesn't have to be Arduino, it can be anything, Raspberry Pi, whatever. Something digital. And over here you've got your mechanical switch sending signals to the board when it gets flipped. Anyway, so you've got this application. E.g., flipping the switch fires up the tokamak drive to make the jump to hyperspace. You're going to need the navigation computers to do that. You're going to need a good switch and some solid switching logic to go with it. Because you built this spacecraft in your garage, your wife doesn't know what's underneath the sheet. And because you're using old transistors you salvaged from your trucker uncle's CB radio, and because you've almost cracked the code to achieve Gabriel Cron's negative resistor, if only you could get your hands on some fissile material to properly dope your homemade vacuum triode craplifier. And of course, more mundane problems keep blocking you from greatness, like switch bounce, or you see random noise in the circuit. Hey, you know, this is expected. And so therefore, because you are building a ship that will eventually be used to single-handedly take complete control of NORAD airspace, you're certainly not going to be using these confounded infernal little bastard momentary switches. No, only the best will do. This, my friends, is American-made, 20th century telephony grade switching. By the way, if anybody knows what this switch was actually originally used for, I'd love to know. Double pull, triple throw. It is gorgeous. Built like a brick shit house. I mean, look at it. Look at these contacts. The cam. Look at the cam. Look at the roller on the cam. The finely knurled knob. Plastic though it may be. I mean, this thing is bomb-proof. Good luck finding that. Time travel, my friends. Time travel. So my guess is an old telephone switchboard thing, but that's about as far as I've gotten with it. I don't know what these acronyms mean. Initiate launch sequence. So, you know, originally I was going to talk about debounce. After starting down this road, I discovered the debounce project in the Arduino examples. I don't really like this code because, I mean, well, it's code. It's relying on a timer to do the job, and therefore there's state checking involved. There's more overhead. Basically, it's not fail-safe and sort of sweeps the problem under the rug. I mean, I want a hardware solution to a hardware problem. I have grown tired of my own hackery. So I keep bumping into these transistor / capacitor shunting circuits that supposedly are designed to reduce bounce and hence noise. So here's one. In the schematic they're using 1K resistors and a 10 picofarad cap. I'm using 10K resistors and a 22 picofarad cap. The 1K wasn't pulling the voltage down enough, so I wasn't getting a solid 0 when the switch was off. I was getting like 1s, 2s, 3s, 4s. Something in there. So I'm not sure about the cap value either. Didn't have a 10 PF, so I took out two 22s in series to get 11.5 PF, blah blah blah. Didn't seem to matter at all. I'll set up the breadboard with just a simple pull down resistor. Take a look at the console and you can see my noise problem. So let's see here. Because right now I've got this thing. What I am seeing when the switch is in the off position and the tokamak drive is disengaged, I get random noise. Switch is in the off position. which should be sending zeros due to the pull-down resistor. There's a little 1 or 2 gremlin getting in there, and the logic states that if you are not a 0, then the switch must be flipped to the on position, and if we aren't already running the tokamak, then run the tokamak, and then the damn thing turns off just as quickly. So, not good. I mean, awful. Terrible. Why not, you ask? Simply check to see if the value on the switch is less than, say, 10 or 20. I'm not getting numbers greater than that. That'll probably work 99.9999999% of the time. But I still want to find a way out of this that would make the hardware crowd and their collective head nod in approval. So this is turning out to be a fail. I mean, it's better than just a pull down, and it's better than the aromatic steaming pile of timer code that ships with Arduino. But at this point, I've got a tokamak plasma drive that's flickering like a fluorescent with a spent ballast, so consider this a step in the right direction. It's half-ass, I know, but it'll get you down the road a piece. And we'll get her licked in part 2. On the next episode, we look at another failed Internet of Things promise. Low on toilet paper? iPhone notification widgets telling you when you're low on toilet paper and why we don't give a fuck. We now conclude telecasting for the day, and because today, ladies and gentlemen, is July 4th in the US&A, our national anthem.